So one, I might just give you a probability distribution and say, here it is, which would mean I give you the x's and the probability of the x's, right? And a table, and you find stuff from there. If not, then there's three distributions we've talked about. What are those three? Binomial, normal, uniform. Good. You can just read off of here too. Binomial. How do you know something's binomial?
It has
two possible outcomes. So you're doing something over and over again, and it has only two possible outcomes. And maybe you think about what the, not what I'm asking you, but what the researcher asked its subjects. So maybe I drew a marble and said, and I asked the marble, are you blue? Right? And I do it over and over again. Are you blue? Are you blue? Are you blue? And I get it. What answers am I going to get on that? Yeses or nos. Right? Like the marble won't answer, but I will answer for the marble. Yes or no. Right? So that would be that's going to be a proportion. That's going to be a binomial distribution. Right? Yes, no. Well, now what color you are, then I have to change that to be binomial to only have two options, red or not red. And that's the only way we can make use of it. So that's your first thing. And then make sure that it only has a fixed number of times you're doing it. I'm only drawing so many marbles, or I'm only flipping so many coins, or I'm only sampling so many people. I know ahead of time how many times I'm going to do this, how many people I'm going to sample, or how many marbles I'm going to draw. And then obviously the probabilities have to stay the same. So if you draw a marble, you have to replace it so the probabilities remain the same. The other thing is, if it says, assume it's normally distributed, then it's normal, right? Likewise, if it says uniform, then it's uniform. Look for those cues, right, so you don't go off and do something wild. So the first thing you should think about is, what kind of problem is this? And look for the cues to make sure that you've got it right, and you just don't say, I don't know what to do. Maybe I'll just try, maybe it's normal, and just do it when you haven't looked for these cues. Even though it says uniform, you're like, I don't know, and you draw a normal curve and you just go, right? So look for the cues. Yep?
What are the formulas associated with normal distribution?
That's a great question. We'll get to that later.
Oh,
Yeah. And the last thing is, does it involve a sample? You're finding the probability of a sample, so a sample size n, and you're trying to find the probability of a mean or an average. So if you're talking about a sample, the mean, then you're looking at central limit theorem, and that's another version of the normal. So those are kind of the things to kind of look for and cue into. I think what I'd like to do is really think about what they're asking. It's really important now to start thinking about not what I'm asking you, what the researcher is asking the people that they're researching, right? So kind of think about that. And why don't you go ahead and do the flip side of your quiz for now. We'll take maybe 20 minutes and work on that.
Like these notes that the class got canceled and all that. So we could fill
Yeah,
it in.
yeah. So what I would do is, if the class got canceled, I would put the notes and the quizzes online, so that you can download them or look at them and write them down.
Okay.
And I would, or I'd have some central location where you could pick up a copy, maybe. I don't know how we could do that.
Just Starbucks.
Yeah. Right. I'll set out in Costco eating some pizza, and you guys can come pick up the quizzes.
That's not bad.
All right. Yeah. Or I'll post them online for sure. But yeah, I mean, there's a chance we might get canceled. You never know. Like. But I mean, here's the problem. Like, as some people pointed out, you guys are all low risk anyways. I mean, you get it. Sure, it will spread more, but it's going to spread anyways. If it gets to a point, I feel like if it gets to a point where we are looking at closing, then we're probably all going to get it anyways.
Yeah.
So that kind of makes sense. I mean, I don't know, it doesn't make any sense. So, I don't know.
If you volunteer to get tested with statistics.
Yeah, I don't know. But you guys, in your 20s, a friend of mine's an instructor, he's like, I'm planning that I'm probably going to get it. And I'm young, so I'm not going to have I'm very low chance of anything bad happening. Yeah. I'm sorry?
Like half of the subjects have been recovered.
In the age group, more than that.
More than that, yeah. Like even people that half of them.
Yeah. Yeah.
Report that on the news, that's messed up.
Okay. Okay, so let's go ahead and go through this because that way you guys don't want to be here late. I'm sure you want to get out of here. Adam, did you do this one?
Yeah.
Go and explain what you did.
First thing I did was I organized the numbers from least to greatest to help me out for later on.
Good.
And then I added all the numbers up.
Mm-hmm.
And I got a total of 128. And I got 8 individual inputs. So I divided 128 over 8
Great.
to get 16, which is my mean.
Terrific. Keep going.
My median, I took the center 2 numbers because it was 2 instead of a
Yep.
singular one. Added them and then divided them by 2.
Mm-hmm.
So I gave me 30 divided by 2, which is 15.
Yep.
And then for my mode, the only one that was repeating in this case was number 13.
Great.
So that's all I wrote down. Number 13 was the mode.
Yeah, you can see it easily there. Great.
And then my mid-range, I added the least and greatest, which was 12 plus 22, which got me 34, and divide that by 2, which equaled 17.
Oh, right. But I think I asked you to find I just said mid-range. Oh, that's weird. Yeah. Yep. Oh, yeah, because it's mid-range. These are all averages. My bad. Yes, that makes total sense. Great. Now, as a reminder, how do you find your Q1 and your Q2? You split the data perfectly in half whenever possible. And then your Q1 is going to be the median of the lower half. So in this case, we'd have 2 things tied for the middle. So this would be our Q1 would be 13. And here, the upper part, this would be 19, and that would be our Q3. Yes? Everybody on board with that part? Okay. And then obviously the min and the max are pretty easy to spot.
Let's say 15 was there, like in between them.
Yeah, so then if 15 was in between them, then you'd have to split them perfectly in half, ignoring the middle, ignoring 15.
And then for the Q1 and Q2, you'd ignore the min and max too, right? Is that what you-
No. The Q1 and Q2, you just Q1 and Q2. You just look at this is my data, my mini data. It's my half, my lower half. What's the median of my lower half? And just find it. If there was a number here, this would still be the lower half.
Okay.
Yeah, you wouldn't include it in either half because you can't split it in half. So you just ignore if there was one in the middle.
No,
Yeah. Good. Amanda, I think you did this one.
Yeah.
All right, do you want to go and explain what you did? You guys quiet.
For the mean, I added up all the original values and I got 80 divided by 5, which is how many values there are. And I got 16. And then for the standard deviation, I had to find how many numbers each value was away from the mean.
Yeah, how far each one was away from the mean?
Yeah.
So see how 16 is 0 away from the mean? You should put 0 there.
Yeah.
18 is 2 away from the mean. And you don't have to, you can ignore the signs in this one case because you're going to square them all anyways. So they're all going to become positive. Keep going.
Yeah, so I squared all of them and then added it all up and I got 94 divided by n minus 1, which is 4, and I got 23.5, which is the variance, so I square rooted it and got the standard deviation of 4.85.
Yep. So this is your standard deviation, the square root of the variance. Yeah. Gina. Yes, absolutely. So yeah, I'm glad you brought that up. So for the exam, this part will be with your basic calculator. You can totally leave it as square root of 23.5. I'm totally fine with that. Don't leave it as square root of 94 divided by 4. All right, at least give me this part. You guys hear what I'm saying? Okay. Good. This one. All right, so mean of 18, standard deviation of 5.8. If I add 7 to every single value, then it's just like that huddle. Remember we had that football huddle and everybody shifted over 3 steps? What changes? The mean, the center changes, and by how much? My new mean is going to be 8, oh actually it's going to be x bar because it's a sample mean, right? So x bar, 18 plus 7, 25. and my new standard deviation is going to be 5.8. It's going to stay the same. Good? Okay. Finish the following statement. A z-score represents,
Standard deviations of values away from the mean.
right, number of standard deviations values above or below the mean. You could, you could also say this. A z-score represents how many,
Standard deviations.
and it still better be standard deviations, a value, or a number, you could put a number, I suppose, is away from the
That's an example.
mean. So you could do that also, right? Because this is the same thing as how many or the number of, and then is away from is above or below, that's fine. But standard deviation and mean have to stay there. There's no other word for standard deviation or mean. Or I guess you could say average instead of mean if you wanted to, right? But standard deviations, there's no other word for standard deviations. That's it. And I guess for a value, you could put a number or something is, that's all right too. So that's the amount that you're allowed to vary. You have to have all these pieces because how many a value is, how many what, right? A value is the mean. The value is the mean, that makes no sense. Away from the mean or above or below the mean, right? And you can't leave it, you can't say how many standard deviations away from the mean. How many standard deviations away from the mean? What is? A value is, a number is. You have to give me that too. Everybody understand what I'm saying? So these 5 pieces all have to be there. If you're missing any one of those pieces, you will lose credit on this. I have to have you, everybody understand what I'm saying? Those are all super important. Because otherwise the sentence doesn't mean what it means. Good. Great. I think Rizzo, you did this first part?
Yes, so
Go ahead.
you're gonna find the values for both 140 and 128. So you can take 140 and you subtract it from the mean, which is 124, and divide it by the standard deviation, which is 4.5, and got 3.56.
Great.
Then we'll do the same thing for 128, which we got 0.89.
Good. Because remember, I'm either going to give you one value and expect you to find the probability below or above it, or I'm going to give you 2 values, which means you have to find 2 z-scores, one for each of them, and you need to find the area between them. So that's the first part. And then you also did B. Go ahead.
Then you take the z-scores that you got for both those, and then you do normal CDF, and you take your lower one, which is 0.89, and then you do gamma 3.56, which you got 0.8265.
Great. And then Haley, C.
The probability that the weight of the field mice are between 128 grams and 140 grams is 18.65%.
Perfect. There is another way of saying this. You could have said something else that's similar but different. Anybody do the other one? Everybody did this? Everyone did probability? What did you do?
Is it okay if it's shorter? So we have
Yes.
to say probability, right? Or
No, you don't have
so
to.
If it was just like 18.65% of the population is between 128 grams and 140 grams.
Right. I would say of field mice instead of the population.
Okay.
But yeah. But so that's the other way of saying it. The percent of population, right? So 18.65% of the population of field mice is between 128 and 140 grams. Or what did you say? So you said again, listen up, you guys.
18.65% of the field mice are between 128 grams and 140 grams.
So either one of those, because percent of population is the exact same thing as probability. Good? And then go ahead and explain your picture here. So she has her curve, I'll explain it.
Yeah.
And then she has the line and she has the notch, just like I wanted. And then she put in a line where the z-score is 0.89, which is the same thing as the value of 128 grams. She also did put in the z-score for 356, I drew a line up, which is also the same thing as the value of 140 grams. So these are your X values. These are your Z-scores. And then she shaded in between them and put in the area. The area goes in here. Good. Okay. Everybody on board with that part? Yes?
Yes,
No?
ma'am.
Great, thank you so much. Now, this looks for, I think we talked about this already a little bit, right? All right, so I want to ask you guys this question. With your neighbors for a minute, try to figure out what the distributions are we've seen and information about them. So take 30 seconds to just figure out what are the distributions we've seen. So talk to your neighbors, 30 seconds. All right, so someone give me one. Uniform. Binomial. Good.
Normal.
Wait, hold on. I'm going to go this way. Hold on.
Binomial.
Binomial.
Normal. Inverse.
Normal. And then discrete. Yeah, so kind of a discrete table is the other one I've given you. Is a discrete table. So that's the one that looks kind of like, you know, that X and the probability of X. And this could be like 1, 5, $10. You guys remember that one with the probabilities?
Oh, that's that one.
Yeah, that one. Okay, so then, uniform, what does that look like picture-wise? Yeah, like a rectangle, right?
Oh, the box.
Oh, actually, it doesn't even look like that. It looks like, yeah, like that, Binomial. Anybody remember what binomial looks like? Oh, it doesn't matter, actually. Binomial looks like either like, depending on what your P is, it'll look sort of like, it'll be really skewed off this way, or it might be skewed off the other way, something like that. Normal?
Bell curve.
Bell curve. Good. Everybody okay with those parts? Great. Now, the next thing we should think about is stuff like, how do we find the mean and how do we find the standard deviation? That's the other thing you probably need to know. So why don't you take a minute with your neighbors and try to figure out anything you need to know about this. Like, how do you find the area of it? If you need, or how do you find a probability? How do you find a probability? How do you find the mean? How do you find the standard deviation? Any other sort of information you think you might be useful. So take a minute with your neighbors and try to jot that down. Maybe 2 minutes. And then we'll go over that. So uniform, what are some things we know about uniform?
It's like, find the height.
Yeah, so height is equal to 1 over the length. Okay, that's good. What else? Anything else?
Area
Area, how do you find the area?
equals length times height, or times width.
Yep, equals length times the height. Good. So those are probably the things we need that are important for that one, right? How about binomial? What do we know about binomial? Yeah, it's a, the question is yes or no? Is it yes or no? Does that make sense? Okay, what else? What was that? It's discrete. Good, we know that. What else do we know? Yeah, the probability. How do you find the probability of it? Probability of x is equal to what? And choose x times little p to the times little q to the n minus x. We need more room. N minus x. Good. How about how to find the mean and standard deviation? What's my mean? NP, and my standard deviation is square root of NPQ. Don't forget square root. Good? All right. Now, what else do we have? Normal distribution. What do we know about that one?
Symmetrical.
Symmetrical. Good. Symmetry. I always put symmetry. Good. What was that? What else? You know nothing else about normal distributions? Yep. How do you find the mu? Oh yeah, so the mu and the SD are given.
Yeah.
Mu given. Standard deviation given. Good.
Present.
Yeah. Was that?
Sorry.
What? Okay. Anything else? Like how to find the probability? Oh yeah, so find the z, so z-scores. It has z-scores. And then you also use normal CDF. Of the, oh man, this, I should have written sideways instead. Of the Z1 comma Z2, does that seem okay?
Yeah.
Yeah.
Is the probability? Good. Okay, so those are some things. Okay, that seems all right. How about this discrete table? How do I find the mean? Do you guys remember how to find the mean? Anybody remember that one?
Times P times X.
Yeah. The sum of every x times its probability. Every x times the probability of x. So you take every x multiplied by its probability, and then you add all those up. How about the standard deviation? You remember that one?
X squared.
This one,
Just do the list.
just do the lists with 1 var stats. But make sure you do 1 var stats of L1 comma L2. If you just do L1, it's going to assume that the probability of each one of them is 1. Do you guys understand what I'm saying?
Yeah.
Yep. Right. Okay. And then probabilities. Like, what do I? If I want to find the probability of 5 or more, what would I do? I remember this one. You just add these because we gave them to you. So if you want the probability of 5, it's just this one right here. 5 or more, you just add those.
You have
Very
like
good.
P of X's?
I'm sorry?
You had the
I would give you, so this one, I have to give you the X's and the P of X's. Well, in a sense, I might do grab bags and you have to figure them out yourself, right? If there are 20 grab bags and one of them has $20, then that probability is 1 out of 20.
Were you covering quartiles as well?
I'm sorry?
Quartiles as well?
Yeah, so you guys need to do quartiles. Maybe we'll go over that during the review tomorrow. So this seems good for now. We're out of time. I will see you guys tomorrow.